Hello, how are you? I hope all of you are fine. So we can for the another lab. It is the lab 11. So in this lab, it is a UV visible spectroscopic analysis plus back titration. Okay. So in your book, it is written only the UV visible spectroscopy, but here we will also learn the back titration as well. So you know what is the back titration. In the back titration, we normally add known concentration of some excess amount of the known concentration, then that excess amount we can find out with the help of the other known concentration of the substance. So UV visible spectroscopy and back titration. Here in this lab, actually this is one of my favorite lab, because as I mentioned at the beginning of our semester, that so in the analytical chemistry we normally learn different techniques to find out the concentration, the qualitative and quantitatively the like the qualitative and quantitative analysis of any substance. So this is a very good demonstration to find out the quantitative amount of the of a complex compound. So this one actually contains three things. One is nickel, another is ammonium, and another is chlorine. So what we'll do, we will give you a salt, a complex salt, okay, of nickel ammonium chloride. Okay, nickel ammonium chloride. So in this nickel ammonium chloride, we will not give you what is the empirical formula. Nickel, this is X, this is Y, this is Z. You have to find out with the help of the UV visible spectroscopy and back titration. You have to find out the what is X, what is Y, and what is Z. Okay. So UV visible spectroscopy. So what is X, what is Y, and Z? So if you take a look at this, you will see that this is nickel, this is ammonia, and this is chlorine or chloride, whatever. After that it will become chloride. So this one you actually don't know how to find out the amount of the nickel. But if you take a look at this ammonium, you know that is a base. So if it is a base, we can find out the amount of the base by the help of the acid-base titration. We know that, right? We learned it. And what is the how can we find out the chlorine? For today's lab, we will not actually find out the amount of the chlorine. Okay, we will find out the amount of the chlorine in some other way. So, but if you need it, you can find out the chlorine with the help of the silver chloride. The silver chloride, if you add the silver nitrate, it will produce the silver chloride precipitated. So anyway, for today's lab, we will find out the amount of the nickel. You know the amount, how to get the amount of the ammonium, but you don't know what is the way to get the nickel. So nickel is the so this nickel is a transition element. Okay, what is the transition element? Which has the empty d orbital. Okay, in their structure, when it has the empty d orbital, it is a transition element. So you know that transition element shows variable oxidation state, and as well as transition element give the colorful compound. Which are the colorful compound? We can find out those colorful compound, the amount of those colorful compound with the help of the UV visible spectroscopy. Okay, so UV visible spectroscopy for the nickel, it has a specific lambda, like it has a specific wavelength at which its absorption is the maximum. Okay, it's called the lambda max. At a specific wavelength, the nickels give a maximum absorption. Okay, and for the nickel it is 395.8. Okay, for the nickel it is 390. If instead of nickel, if you will use the copper, or if you will use the iron, it will be different for the different. And but this wavelength is specific for the specific metal. Okay, so for the nickel it is 395.8. Okay, so let's see how actually UV visible spectroscopy works. So you know what is the visible spectroscopy. Visible is 400 to 800 nanometer, right? But UV, that means some other range. So this is 400 to 800 nanometer, the visible range. Okay, light. So UV, since UV also included, so we are actually UV start from the 200. So we will actually use from 200 to 800 nanometer of the light, and we will use this as a light source. So we will use a light source Okay, this is actually a small machine. So how the machine work, I'm just trying to explain you a little bit. I think Dr. Zhao also already explained you in the class. Anyway, so this will be a light source. So if your light source, the light comes from there, and then there will be a slit. In this slit, it only let you go the 200 to 800. Okay, since we are analyzing among that range, and you will have some sample here. We call it the cuvette. Okay, cuvette is look like this cuvette. It's a like that. Okay, you accept the length. This is 1 centimeter. This is 1 centimeter. All through the 1 centimeter. So anyway, this cuvette we will use. So you will use the cuvette to put the sample in, and the light source from here to here will go through this. Okay, if it go through this, then what will happen? So it will absorb the light. Okay, it will absorb the light and it will transmit some of the light, right? If the concentration increases, then what will happen? It will absorb more, right? If the concentration is less, it will absorb less. Okay, but we will only detect the transmitted one. Absorbance one we cannot detect, right? So you'll detect the transmitted one. So with the increasing of the absorption, with the increasing of the concentration, the absorption also increases, and with the increasing of this law is called with the increasing of the concentration, the absorbance increases. It's called the Beer-Lambert law. Okay, you will learn it. So Beer-Lambert law, I think you Dr. Zhao already discussed it in your class. Anyway, so after transmit, and then it will be converted through the spectra, different spectra. So from this spectra, we can identify the amount, we can identify the element. Okay. So the first thing is that, as I said, first thing is that you have to know the lambda max. Let's see how to find out the lambda max. So in this video, I take this video from somewhere else. In this video, it will show the 600 nanometer, but for our lab it will be 395.8 nanometer. We will use the 395.8, but in the video it will be 600 around nanometer. That is the same way, almost same way we use to find out the lambda max.
This video will show you how to use a UV visible spectrophotometer. These are the double beam UV visible spectrophotometers in the instrument room in the general teaching laboratory. Take note that the on-off switch is at the right side of the spectrophotometer. Here are all the apparatus that you will need for this setup. A solvent bottle, a waste beaker, a pair of glass cuvette, and a volumetric flask containing your solution. The sample will be placed in the cuvette for measurement. There are 3 types of cuvette, one made of plastic, glass, quartz. A common feature of all cuvettes is that each one has 2 opposite opaque sides and 2 opposite transparent sides. You will hold the cuvette by the 2 opaque sides. The transparent sides are meant for the pathway of the UV or visible light. This is the UV visible spectrophotometer. To conduct a scan, you will need a pair of cuvettes. For the first run, we have to do a blank solution scan and auto-zeroing, meaning that both the reference and the sample contains just the solvent. We should rinse the cuvettes with the solvent being used. Here we are using water. Fill this with the solvent. Put on the cap. Shake it and dispose the liquid into the waste beaker. You can rinse it again. Now use the Kim wipe to clean the transparent sides of the cuvette. We have to make sure that there are no fingerprints, grease, paper lint, droplets on the transparent sides of the cuvette because light is passing through here and we don't wish the light rays to be refracted. Open the lid of the sample chamber. Insert the cuvette in a way that the transparent sides are in the east-west direction. That's where the light is coming from. There are two cuvette holders labeled blank and sample, so place them accordingly. Close the lid and do the auto zeroing. There is a manual placed next to the machine. You may refer to it anytime. Turn on the machine and wait for it to initialize. So on the control panel, we press the button 2 to access the spectrum. On this screen, we will see the scan range and we should assign it as 800 to 400 nanometers. The absorbance value we use is from 0 to 1.5. Make sure these two rows data are correctly inputted. Following the manual, press Auto Zero. You know it is done when the spectrophotometer beeps a sound. Take out the sample cuvette. Discard the solution and we are ready to run our sample solution. Remember that the cuvette still contains some solvent. We need to rinse it again with our sample solution a couple of times to ensure that the solution we are measuring is not diluted. Take note, for quantitative analysis, it is vital not to let solvent remnants to dilute and affect our results. Now slowly pour in some of our sample into the cuvette. Put on the cap, rinse it. And dispose it into the beaker. Repeat this cycle again. Now we can fill the cuvette to 4/5 of the height with the solution. Use the Kim wipe to clean the transparent sides and place it into the sample holder. Close the lid. Press Start on the control panel. Notice how the graph is forming. The lines tracing from 800 nanometers to 400 nanometers. And we have a peak the maximum absorbance at about 600 nanometers.
Okay, so you saw how to find out the lambda max. So you got the lambda max this. So once you got this, as I said, so this at this lambda max, it gives specific character. So at this lambda max, we will try to find out the we will use this lambda max to find out the concentration of the nickel. So to do that, first of all, as I said, we will give you nickel ammonium complex. Okay, so nickel and ammonium actually very tightly bond with each other, so it's very difficult to break this bond. So to break this bond, if we use the diluted acid to get the amount of the ammonium salt, okay, then what will happen? It will not give you the sharp peak. Okay, it will not give you a sharp peak like the acid base titration. Okay, but instead of that, what we do, we do the back titration. So we will add excess of acid. Okay, we will add excess of acid to neutralize the ammonia, as well as some acid will remain in the solution. Clear? So if some acid is remaining on the solution, from that amount we can find out the what was the concentration of the ammonium. You know that is called the back titration. So once you know the amount of the nickel and then you know the amount of the ammonium, okay, the rest of the things is what? Chlorine. It's easy. Okay, so you know the amount of the nickel with the help of the spectroscopic analysis. How to do that, I will let you know. Then ammonium is from the back titration and chlorine is the, so if it is 40%, sorry 30%, if it is 40%, the rest is 100 minus 70, so it is 30% is the chlorine. We can find out anyway. So to do that, what do you need to do? First of all, you need to find out you need to dissolve the things in the, first you have to take the 5.311 gram of the salt, nickel ammonium salt. Okay, nickel ammonium chloride. You have to take the 5.311 gram of the nickel ammonium chloride. So once you take it, then you are going to add 2 molar 75 ml of HCl. We know that is excess. Whatever the excess, you will find out. Okay, later on. So this is 2 ml of 75, 2 molar of 75 ml HCl. So, and you take it in the 100 ml volumetric flask. Okay, so in the 100 ml volumetric flask, you have taken 5.311 gram of the nickel ammonium salt, and then you are taking 2 molar 75 ml of the HCl. Everything is dissolved, and you see that there will be a blue color. Then rest of the things you can fill up up to the mark with by adding the 25 ml of the water, deionized water. So you have, this is called we call it the unknown solution. Okay, you don't know anything, only the gram of the nickel ammonium salt. So, and by this time we already know how to find out the lambda max. We got the lambda max. Okay, now what you need to do, you will take 1 2 3 4 5 6 of the test tube. We provide you the 6 of the test tube, so you will give you 6 test tube, then test tube, and there will be a nickel chloride solution. This is the standard solution we will give you. Okay, so this is a nickel chloride solution of 0.5 molar. Okay, so from here, okay, we will take, you have to make standard carb. That means so we will make a solution of 0.1 molar, 0.2 molar, 0.3, 0.4, 0.5. It is actually same as this one, and this is unknown. Okay, so how to make it? We will take 1 ml of this and 4 ml of water, 1 ml, 2 ml of this and 3 ml of water, 3 ml of this, 2 ml of water, 4 ml of this, 1 ml of water. The whole the things is the 5 ml, and this one is the unknown, 5 ml of this one. Clear? So the what is the concentration of this? This one will be 0.1, 0.2, 0.3, 0.5, 0.4, 0.5, and this is the unknown, you don't know. So take a cuvette cuvette is look like this. I am not drawing the whole thing. So cuvette is look like this, and 2/3 of the things, 2/3 of the cuvette, first you will clean it with the water few times, and then as you saw that first you have to do the blank. So you put this one as a blank first. So after the blank, then you are going to wash it with the water and put this one first a little bit, wash it. This is called rinse it, and after rinse, then you again put it. Okay, after putting, then find out the absorbance. So when you are going to find out the absorbance, at that time you have to put the lambda max. So yeah, in the computer you have to put this lambda max 395.8. whatever the lambda max you will get, this lambda max you will put, then run the sample, and you will see that a point. Okay, that point, suppose the absorbance is 0.25. okay, I gave you the data 0.25. so the same way you are going to do for the 2, 3, 4 and 5. okay, and for those you are getting the data of absorbance at 0.5, 0.75, 1.00 and 1.25. this is 1.25. okay, and then the same way you are going to put the unknown. okay, unknown, and you got 0.575. okay, by using all this data 1, 2, 3, 4 and 5, you are going to plot an absorbance versus concentration plot. okay, you are going to plot an absorbance versus concentration plot. So from here, then unknown, put the unknown somewhere over here. okay, and you will get an y equal to mx plus c. okay, so put this value and find out the absorbance, find out the concentration x. Y it will be this one and x will be this one. So find out the x. This is good. So you find out the x, and that x is actually the concentration of the unknown, right? So you know the concentration. So this unknown is a concentration of the nickel in your unknown sample. okay, concentration of nickel in the unknown sample. So suppose we call it the C. okay, so if it is C, this is the C, whatever you will get from here, this is C. Then number of moles of unknown. What is the number of moles of unknown? This is actually number of moles of unknown. This is the concentration here. So number of moles of unknown is in 100 ml. okay, how can you get it? Concentration multiplied with the volume in liter. okay, so then you will get the number of moles of unknown. okay, suppose if you call that is an A, number of moles of unknown is equivalent to A. okay, so this is the number of moles of unknown. You got it. okay, so what is the molar mass of nickel? It is 58.7. the molar mass of nickel is 58.7. okay, so then if you multiply that, then you are going to get the gram of nickel. okay, then you are going to get the gram of nickel. So what about the gram of nickel? okay, divided by the 5.311, you will get the percentage of nickel, right? Clear? So the amount of nickel, you got it, everything. Now come to the ammonium part. So here what we did actually, we have added 2 molar of 75 ml of HCl in 100 ml, right? So 100 ml contains what? 75 ml of 2 molar HCl, right? So here what we will do, we will take first 10 ml of this. okay, anyway, so here what we will do, you have this amount of HCl, so number of moles is at around 150 millimole. okay, so you have 150 millimole of the HCl you added of HCl you added. But at the beginning you had some ammonium, and you know that this is an excess of the HCl. So if it is in excess, okay, whatever the number of mole it was there, first some of the acid used to neutralize the ammonia, right? Then some of the things was excess in amount. So from that excess amount we will find out how much of the HCl was excess. If we know the how much of the HCl was excess, then we can find out the how much of the HCl was reacted, that is equivalent to the amount of the ammonia. Okay, so anyway, so you have this you have added this millimole of HCl into here. Okay, so now so you have to do the back titration. So what will you do? You will take the 10 ml of the unknown, okay, 10 ml of unknown, and add 15 ml of water and do the pH metric titration. Okay, so what will be the pH here? It will be acidic. So pH metric titration with 0.1 molar sodium hydroxide. So you have in your drawer, you supposed to have 0.101 molar. I am giving you the concentration 0.101 molar sodium hydroxide. Okay, so you have this and you put it in the burette. Okay, in the burette you put it, and then you are going to titrate with the 10 ml from here. Okay, so if you are going to 10 ml with here, then what is going to do? Then you run 3 titration. One is 12.1, 12.0 and 12.2 and 0.00 ml. So this is the amount of sodium hydroxide you needed to neutralize the excess acid. Again, excess acid. Okay, so this is the number of moles of sodium hydroxide you needed to neutralize the excess acid. So if this is the excess acid, okay, this is the base, you know the molar concentration of the base, the concentration of the amount S1V1 we will use. So you know it is 12.10, okay, and volume you know the concentration 0.101. okay, this is the concentration of the sodium hydroxide, this is the volume of the sodium hydroxide, 12.10 for the first one, and you don't know the concentration of these, but you know the volume of this. This is 10 and this is Y, suppose. Okay, so from here Y1 you can easily get the concentration of the acid here, and this concentration is actually what? Excess acid. Okay, so if you know the concentration of the excess acid, can you find out the number of moles of excess acid in the 100 ml? Can you? I think you can. How to do that? So what is the number of moles in excess acid? Y1, whatever you will get, this will be around, you do that calculation, you will get the Y1. Okay, so if you get that Y1, then this is the concentration. That means concentration means what? In 1000 ml. Okay, so in 100 ml it should be what? Number of moles you can get it. It should be multiplied with the volume in liter. Okay, so you will get the number of moles of ammonia here. Okay, so if you multiply the number of moles of, so this is the number of moles of ammonia. Okay, if you multiply this one with the molar mass 17, you will get the what? This is the molar mass. you will get the mass of ammonia. Right? You will get the mass of ammonia. So once you get the mass of ammonia here, then what can you do? You can get the percentage of ammonia, like here, percentage of ammonia. How? Whatever you will get, if I call it Y2, okay, percentage of ammonia will be Y2 divided by 5.331, sorry, 311. Okay, that will be the percentage of ammonia. What about the percentage? This plus this minus 100 will be the amount of the chlorine. Okay, suppose for example this is 30. Suppose for example nickel is 30%, ammonia is 40%, chlorine is 30%, right? So from this percentage you have to find out the empirical formula. What is X, what is Y, and what is Z. How to get this? There is a demonstration in your lab notebook at the end of this lab. You will see that question number 22 maybe, and there is a chart. Okay, there is a chart on your lab notebook. You have to fill it up, okay, with this data. What I have given you, the data, so you have to fill it up with the data, okay, and the number will be assigned over there. So take care and stay safe. See you again on the next week. If you have any question, you feel free to send me. Okay, take care. Bye.